Hello everyone and welcome to the second day of Law of Sines. Some of you may know this is my second time recording this video. I recorded a 35-minute video and then it didn't save and I'm mad about it. So if I seem a little exasperated in this film, that is why. I may have thought I've already said something when I didn't. I may just be kind of grumpy. It is not your fault. I'm just mad at technology and myself. Anyway, so you're not here for that. You are here for learning about the ambiguous case for Law of Sines. Now, in our last video, we've already started the ambiguous case, which is when you're given side angle. But in the last video, the angle we were given was greater than 90. Now we're looking at the specific instances when the angle is less than 90 degrees. So we're going to have three different scenarios here. I'm going to explain the three different scenarios, and then we'll do an example of each one. So first example we're going to have is a no solution. So a no solution might look something like this. Something that doesn't even make a triangle. So for instance, say I'm given this angle here, this side, and this side. You'll notice that that side length of A doesn't even connect to the other end because it is in fact smaller than the height of the triangle. So since it is smaller than the height of the triangle, right here, as we can see, it doesn't even connect. This is going to give us a no solution. So the way that we check that is we say that, hey, that A value's less than the height. That's not going to work. Keep in mind, it's not always going to be A. In this case, A just happens to be the side opposite from the angle that I'm given. So instead of always saying A, we can also say just the opposite side from the angle that we're given is less than the height. So this is what we need to check. This is an example of a no solution. The next one is going to be of a just a one solution problem. We'll see how this goes. So the next one is of a one solution. So that may look something like this. There we go. So if we're given this angle, this side, and this side, I'm going to first check against the height. Here, I'm first going to check against the height and see, okay, is this side right here, is this opposite side greater than the height? Yes, it is. It connects to make a triangle. Awesome. There's one other thing I have to check. Let's see, I practiced this yesterday. Hopefully this will work. We'll see how this goes. Okay. I gotta hold this down. If I hold this down, there's a way to make this rotate. Nope. There we go. I'm not deleting that. You'll just have to have fun with that. Okay. So you should be able to see here that if I take this side length of A and I swing it around, it never reconnects with the triangle. And that's because this side length A is so much longer than the side length B that it just goes straight past it. I know that I can make this different sizes, but I'm doing my best to keep this the same. So because it goes straight past that side length B and is so much longer, this is only ever going to connect in one spot, creating just one triangle. So here, there are two things that we had to check for. We had to check to see that that side length A over there is greater than the height, which it was. It made a triangle. But we also had to check that that A value there was also greater than the B value. And you know what? I'm going to include or equal to for these because it creates a right triangle that way. So things end up working out. So in this case, we need that opposite side to be greater than or equal to the height, but we also need that opposite side to be greater than or equal to the adjacent side to the angle that we're given. So I'm just rewriting the same thing with the letters, just a little bit more generally. So that's how we create a one solution. The last one, fun way, is a two solution. Now, if you remember going back to your geometry days, you'll remember that SSA never worked for congruency statements because you can't always necessarily make the same triangle, and I'm about to show you the reason why. Oh, I can do two. Oh, this is cool. Okay, I'm learning something new every day. So let's move this up, and let's do a two solution. So let's see, a two solution may look something like this. We have A, B, A, okay. Checking the height here. First thing, this A value, or the opposite side, is greater than the height. It makes a triangle cool. But if I try to do that thing again where I move around that side length of A, again, let's see if this works. Oh, no. We're going to go back and try that once more. I'm doing my best to do this without any pauses. Okay, fourth time, here we go. I'm having a lot, you can tell, just guess the struggle kind of day. Let's see if we can get this thing moving. I'm trying to highlight this blue line that I just made, and it's not going to let me. I swear it works every time that I'm not recording. Okay, you know what, we'll position that there, set the auto. Oh my god, it's working. I'm so excited. Okay, anyway, I don't even remember what I said because that was like 5 minutes ago. If we take this side length A and we rotate it around, I can see, oh look, it reconnects. I know it's a little off in the center, but oh look, that side length A reconnects with this triangle. It is in fact shorter than that side length of B. So if I take this side around and I reconnect it, I have another triangle here with with angle A, side length B, and side length A right here. So what I'm looking at is this triangle right here. I've made another triangle with the exact same measurements, those same three pieces of information, compared to this one, which also has the same three pieces. So this is why it would never work for the congruency statements. So for our situations, let's see, we were doing this in blue. First thing we had to check is my opposite side, or A, greater than the height. Yes, it is. We're good there. But in this case, our A value, or that opposite side, is now less than the B value, or the adjacent side. So again, you're not always working with A's and B's. So another way to say this is that always got to check to see if your opposite side, opposite from the angle that you're given, is greater than your height, and check that if the opposite side is less than that adjacent side, that is going to give you a two solution. Now, on the test, I'm going to have you identify how many solutions a triangle might have. That is going to be something I'm going to test you on. However, I may not have you solve for everything. For instance, I'm going to show you how to solve for a two solution later on in the video, but I'm not going to have you do that on the test. I will have you identify a two solution, but I will not have you solve for a two solution. Anyway, like I said, I've got 3 examples to go through with you. Let's do it. Let's move this up. Let's see, example number 1. I'm going to give you, say that angle A is 42 degrees. Side length A is 22 degrees. And side length B is 12. So let's see, if I was to draw this triangle, and just a reminder, my triangle's not always drawn to scale. A, C, A, B, C. Okay, let's see. We said angle A was 42 degrees. We said that side length A was 22. Side length B was 12. So the first thing we need to do is we need to check, is that side length A or that opposite side, is that greater than or less than the height? Now, you can't always tell by the drawing. Like I said, I don't always draw to scale. I haven't actually shown you in this video how to solve for the height yet. However, I actually did go over it last class period or last video. If you remember, if we're looking at our angle A, we can say that sine of our angle A is opposite, or H, over the adjacent side of B. This comes from creating the right triangle. So if I was to get H by itself and multiply both sides by B, I can say that B times sine of my angle A is equal to H. Or again, if you're not using B's and A's, you can just say that the adjacent side times sine of your angle is going to give you your height. So we're going to just do that real quick. Oop, I missed the equal sign. We're going to do that real quick every time. So for us, our height is going to be equal to 12, our adjacent side, times sine of 42. And that is going to give us 8.03. So first I have to check this with my opposite side. Let's see. I'm actually going to do this the other way. 22 is greater than 8.03. Okay, so my opposite side is greater than my height. Cool. We know it makes at least one solution. Let's keep on checking. Let's see. 22 is also greater than 12. Or our opposite side is also greater than our adjacent side. So I can see here that since my opposite side is greater than my height, and my opposite side is also greater than my adjacent side, this is just going to give me a 1 solution. Now that we know we have a triangle with just one solution, we would solve like we normally would. So let's do that. Let's make, oh, I'm still in red. Okay, so let's do, let's see, sine of 42 over 22 is equal to sine of B over 12. So I'm just setting up the ratios that I know. I'm first going to cross multiply. I gotta move this just a little bit. There we go. First I must cross multiply so that we get 22 times sine of B is equal to 12 times sine of 42. I'm going to divide both sides by 22 and get sine of B is equal to 12 times sine of 42 over 22. And then in order to get B by itself, we have to use sine inverse on both sides. So our angle B is equal to sine inverse of all of this stuff. And when I plug this into a calculator, please remember to use, to round to the first decimal place for angles. That is going to give us 21.4 degrees. So I'm going to go back and write that in my triangle. 21.4 degrees. Okay, so now that I have that, I can find my angle C very quickly by just doing 180 minus the other angles. So let's move this up. So I'm going to do C is equal to 180 minus 42 minus 21.4. And that's going to give me 116.6 degrees. And I'm going to write that in my triangle. And then last but not least, I have to go back and solve for my side length of C. So let's do a similar setup. Let's have, actually, no, I'll do sides on top just so you can see what will happen. 22 over sine of 42 is equal to C over sine 116.6. So you'll notice that now that I have my sides on top, when I cross multiply, I'm still going to end up with c times sine of 42 is equal to 42 times sine of 116.6, which is exactly what I would have gotten if I had started with my angles on top. So I just want to show you that no matter how you start that, you're going to get the same thing. From here, I'm going to divide both sides by sine of 42. We get that c is equal to 22 times sine of 116.6 over sine of 42. Now, for a side length, we're going to round to the second decimal place, and this ends up being like 29.398. We'll just call this one 0.40. I'll go back and write that in my triangle. Now, I always go back and write this in my triangle because that's just kind of a nice place to see all of my answers. And this is an example of a one solution. So we have two more examples to go through. You may be able to guess how many solutions each of those have. But let's go through problem number 2. I'm going to move all this up. Left. Let's see, with problem number 2, I'm just going to remember how okay. Excuse me. Let's see, problem number 2, our angle is going to be 85 degrees. Side length A is going to be 15, and B is going to be 25. So when I draw this out, again, not going to be to scale. A, B, C, C. Okay, so let's see. We know that angle A is 85 degrees. We know that side length A is 15, and side length B is 25. First thing we need to do is we need to check and see, is my opposite side, or that 15 there, greater than my height? So remember, when you're checking for the height, that is going to be, in this case, B times sine of A, or your height is equal to your adjacent side times sine of your angle. That particular part you don't have to write every time, but every time I do want to see how you're solving for the height. So now I'd go H is equal to 25 times sine of 85. So I do at least want to see that line. Now, when I plug that into the calculator, I get 24.9. So let's check this out. I'm going to compare, let's see, 15 is less than 24.9, or another way of saying that is that my opposite side of A is less than my height. Uh-oh, that's not good, because that means what we really have here is something that looks like this, where it doesn't even connect to the other side. So this is going to be an example of a no solution. Now, if for some reason you forgot to go through and check on this stuff and you were just like, oh, it's a math problem, I'm just going to do the math. If you started to quote unquote do the math and plug this into your calculator, you're going to end up with a domain error. So if you're going through doing your work and you end up with a domain error in your calculator, maybe check once just to see if you plugged it in wrong. But if you keep getting a domain error, it means it's a no solution. You physically cannot make this triangle, which is okay. That is a possibility. Just show me the work that you know it's a no solution, and you're good. So for our very last example, by process of elimination, you may be able to guess how many solutions this problem will have. Let's go through it anyway. So for problem number 3, we're going to say that angle A is 20.5 degrees, because why not throw in some decimals? We're going to say that side length A is 12, and side length B is 31. So if I was to draw this triangle, ooh, that was a thing that just happened. All right, there we go. B, C, C, A, B, C. Okay. We know that A is 20.5 degrees. My side length A is 12. Side length B is 31. First thing I gotta check for is that height. So remember, height is B times sine of A, or your adjacent side times sine of your angle. So for us, height is going to be 31 times sine of 20.5, which if I plug into my calculator, I get 10.86. So let's start comparing. I see that 12 is larger than 10.86, so my opposite side is greater than my height. That's good. It means we have at least one solution, but let's keep checking. I also see that 12 is less than 31, or that my opposite side is less than my adjacent side. So when we see that, we go, oh no, that's going to give us a two-solution problem. So this is the point that I need you to be able to get to. You are identifying that this triangle will result in two solutions. I will be asking you to do this on the test. From here on is just kind of extra for knowledge, good of the order. I'm not going to have you solve for a two solution on the test, but however, you are going to have to do this, identify the number of solutions. So if you want to stick around, excellent. If not, fairly well. The keyword is whiplash. So if that's the last time you hear, the keyword or word of the day, whatever we want to call it, is whiplash. But if you are sticking around, thank you very much. Let's solve for those two solutions. The cool thing is that the first solution that we find, you solve just like you would any other law of sines problem. So let's do that. Let's do sine of 20.5 over 12 is equal to sine of B over 31. First, I'm going to cross multiply and get, actually I'm going to do this the other way around. There we go. I'm going to do 12 times sine of B is equal to 31 times sine of 20.5. There we go. From here, I'm going to divide both sides by 12. And then to get B by itself, I need to use sine inverse on both sides. So what I'm writing now, this is the minimum amount of work that I want to see. I kind of took out all those red steps, quote unquote, from earlier. This is the minimum amount of work I need to see. As well as the answer, which we're going to round to the first decimal place, which is 64.8 degrees. Go back, write that in my triangle, and let's keep solving. So let's see, now that I have this, I know that my side length C, pardon me, not side length, angle C is going to be 180 minus 20.5 minus 64.8. Ooh, it's run to our other work. And that's going to give us 94.7 degrees. Let's go and write that in. It's a 4. There we go. 94.7 degrees. Last step we need to do is solve for our side length of C. And I'm going to do that down here because I kind of ran out of space. So let's see, we'll do sine of 20.5 over 12 is equal to sine of 94.7 over C. Cross multiply and get C times sine of 20.5 is equal to 12 times sine of 94.7. Divide both sides by sine of 20.5. And this is what you get. Again, this is the minimum amount of work that I need to see. I'm showing this to you without the red steps. There we go. So I need to see at least those 3 steps when you are solving for a side length. And when we plug this into a calculator, we get 34.15. put that into my triangle. And these are all the answers for our first solution. Solving for our second solution is when things get kind of messy. Now, if we were in like an actual class, I have a whole activity with like big pieces of paper and rulers and colored pencils, and like we do a whole thing and it's a lot of fun. Unfortunately, we can't really do that here. And you have seen how great my technology skills are. So if you have any questions on this, please come into the Zoom meeting. I also have kind of an informational sheet that helps explain this a little bit more. I'm putting this on Canvas under Law of Signs charts. So there's a few different pages in there explaining things a little bit differently. But it's the Law of Signs charts. So go take a look at that. It's going to explain what I'm about to explain, but maybe just a little bit more clearly, we will see. So here's the thing. We've already solved for our first triangle, our really big triangle, but how do we go and solve for that much smaller triangle that I highlighted? So let's take a look. So I'm going to redraw the triangle. That is still in bright green. Okay. I'm going to redraw and then erase those little markings I made. Oop, there we go. Okay. So if this was my original triangle, that I have, I say, okay, I'm going to take that side length of A and swing it around. I'm going to try this once more. I'm going to let you know, I guess you'll see in just a second, whether this actually worked or whether we're just going to pretend. And to absolutely no one's surprise, we're just going to pretend because I don't know what I did. I got some things spinning, but like spinning on their own in a very weird way. We're just going to pretend. So what we're going to do is we're just going to use the laser pointer and say we're going to take this side and we're going to swing it around until it reconnects at about right here. So we're going to have that reconnect at about right here. Now this is also side length A. So the triangle that we are trying to solve for right now is this sliver of a triangle because it still has this angle A, which was given, this side length A, which was given, and this side length B, which is also given. Now we already know some of the information. So for instance, we know that this angle A right here is 20.5 degrees. We know that that side length B, was 31. And we know that that side length A is 12. So we already know all of this information because it's given to us, but we need to go, how do we get to the rest of the stuff? So instead of looking at that green triangle, let's kind of look at the in-between triangle right here. Now this is not one of the triangles we are solving for. This is just going to help us because we notice that, oh, this is an isosceles triangle because we have this side length A and this side length A. I'm going to make a note of that just so we don't forget. I'll do that in yellow. That is in fact an isosceles triangle. Now something we know about isosceles triangles is that their base angles are also the same. So when we look back, this angle B right here, we found that to be 64.8 degrees. That's something we already found. But if that's true, that means that this angle right here is also 64.8 degrees. But I don't want that angle. I want this angle right here because it's actually inside of the triangle. So what I'm going to do is to find my new angle B. I'm going to take 180 for my line that I have right here, and I'm going to subtract my old angle B. So in this case, I'm going to say, hey, my new angle B is going to be 180 minus 64.8 degrees. And that is going to get me a number. Let me check. 115.2 degrees. So this angle right here is going to be 115.2 degrees. So you'll notice much, much larger than the original angle because it's just the rest of that line. But the good thing is, this is hopefully where the confusing information ends, because now we can just solve for that kind of sliver of a green triangle like we would anything else. So we're still going to look for that angle C that's happening right here, and we're still going to look for the side length C of just that small piece. So let's go through and do that. So for my small green triangle, I already have 2 of my angles. So my new angle C is going to be 180, the number of degrees in a triangle, minus 20.5, minus 15.2, and that is going to give 44.3 degrees. So again, you'll notice this angle is smaller than the previous angle C because it's been cut down so much. So it's going to be 44.3 degrees. Last thing I need to do is solve for my new side length C, which is just regular old law of sines. So this is going to be sine of 20.5 over 12 is equal to sine of 44.3 over C, cross multiply. So C times sine of 20.5 is equal to 12 times sine of 44.3. Ooh, I'm running out of space. Divide both sides by sine of 20.5. We get C is equal to 12 times sine of 44.3 divided by sine of 20.5. When we plug this into our calculator, we end up with 23.93. So again, smaller than our previous side length C because side length C got cut down immensely. So change pen color. This will be 23.93. So again, all of this information we found here is for that sliver of a green triangle, and that is our second solution. You will not be asked to do that on a test. You will be asked to identify that it is a 2 solution, but you will not be asked to do that on a test. This is just for future when you may need to know this, but if you've stuck around for this long, thank you. I appreciate you. I hope to see you at some point this week, and have a good weekend.